Welcome to Easy Learning YouTube. What I have for you today is X-ray. We are going to deal with X-ray. After this X-ray, we now go into calculation on X-ray. But let us know the principle of X-ray. You say X-ray is produced in this form, and this tube is called cooling tubes. So, looking at this, you have a block of copper. This is a block of copper, stream of electron, which is hitting to the target. And when it hits on target, it produces X-ray. And the anode, which is the target, is tungsten. Is a tungsten wire or tungsten block. This is a cooling fan. What's the work of this man? To cool, because as this stream of electron is hitting this block copper, there will be a heat, enough heat radiation. And this cooling fan is there as radiator to cool the temperature. Is the water flowing around this to cool it so that it will not burn. Then, this is the element which is generating this electron at low voltage, while this is heated element which bring the stream of electron. Then X-ray started producing as he hits the target, and the speed which he used to strike the target determine the X-ray, the volume of X-ray produced. Then again, this experiment is done in a what we call lead shell. You know that X-ray is not good for the human body. So this experiment is done in a lead shell. This is the window where the X-ray comes out. And while the person performing this experiment will be guided by this lead shell. Remember again that the voltage which apply across this tube is about 100 kilovolts. Remember this, when we are going into calculation, you'll be able to record it. The voltage which across this is 100 kilovolts. Then now, let us read the note. We are asked to define X-ray. We say X-ray or Roentgen rays discovered by Roentgen in 1895 are produced when high-speed electrons are stopped by a target in the Coolidge tube. Look at what we call Coolidge tube. This is a modern tube used to produce X-ray. This is Coolidge tube where the X-ray is produced. Then we say X-ray. We have defined how X-ray is produced by saying X-ray or Roentgen rays discovered by Roentgen in 1895 are produced when high-speed electron, look at the high-speed electron, are stopped by a target in a Coolidge tube. Then we say X-ray produced depends only on the rate of emission of the electron from the heat filament, which can be controlled by the filament current. So this X-ray is controlled by filament current. The current will supply to this filament. We have what we call high current and low current. If I want to generate a stream of higher speed of electron, I have to increase the current supply in this filament, in this heated element, which we call filament, to release the stream of electrons. So the current is being used to control the rate of the stream of electron which is hitting the target, which as well produces X-ray. That's what we are saying here. We say X-ray produced depends only on the rate of emission of electron from the heat filament, which can be controlled by the filament current. The filament current here, which is low voltage. We come here saying the quality of penetrating power of X-ray depends mainly on the accelerating potential voltage. Depends only on the accelerating potential voltage, V. Look at it. Are you going to say it now? Then you say only about 1% of this energy of the electron that strike the target is converted to heat energy. Only about 1% of the energy of the electron that strike this target is converted to heat energy. That's you will see that it's not all the work done that's being used here. Some of the what energy being striking this and being converted into heat. We say is 1% of it, which is generating heat here. As a result of this heat is being generated here, we now use what we call cooling fan to what reduce the heat, because here will be very very hot as this stream is heating it. And that's what we are saying here. We say that what the quality of penetrating power of X-ray depends mainly on the accelerating potential voltage, that's the potential V. Only about 1% of this entire energy of the electron that strike the target is converted to what? Heat energy. Coolidge tube is the modern method for producing X-ray. This Coolidge tube is modern method of producing X-ray. Then we'll come to properties of X-ray. What's the properties of X-ray? We said number one, X-ray are electromagnetic waves of the same nature as light wave, but of much shorter wavelength. This man X-ray is the same thing as what? Light wave. But the difference is that it has a shorter wavelength than what? The light. That means as it has shorter wavelength, it implies it has higher penetrating power more than the light, ordinary, the nature of the light. It has higher penetrating power, but it has lower, shorter wavelength compared to light, but it has higher penetrating power. Then number two, X-ray travel in a straight line and unaffected by electric and magnetic field, suggesting that they are not charged. That means X-ray are not charged particle. It means that electric field cannot affect it. Magnetic field cannot affect it. It has nothing to do with magnetic field. It is neutral to it, meaning that it's not a charged particle. That's what we say. X-ray travel in a straight line and unaffected by electric and magnetic field, suggesting that they are not charged particles. This suggests to us that they are not charged particles. Number two, X-ray affects photographic plates, causing fogging, just as light wave. Because of this fogging, that's why X-ray is used in medical diagnosis. In medical diagnosis, when I say, hence X-ray are used in medicine to detect diseased organs. It's used to detect diseased organs, foreign bodies, and bone fracture. Because of these properties of X-ray, it affect photographic plate, causing fogging, just as light wave. Number four, we say X-ray discharge electric field body, whether charged positive or negatively by ionizing the surrounding air. That means X-ray discharge any electrified body. X-ray will discharge that charge on that body. If we have positive charge and you send X-ray on it, it will discharge it. That will say X-ray discharge electrified bodies, whether charged positively or negatively, by ionizing the surrounding air. How does he do this? He does it by ionizing the surrounding air. When X-ray pass, he ionizes the surrounding air, but then neutralize. That means discharge the positive charge or negative charge the body is holding. Then we have other properties. Other properties of X-ray, we say X-ray ionized gas through which they pass. X-ray ionized gas which through they pass. If X-ray pass through a gas, it will ionize it. That gas will begin to ignite lights. That means X-ray ionize the gas through which they pass. Number 6, we're talking number 6 now. X-ray can be reflected or refracted or diffracted just as light wave. We say that X-ray is is just like a light wave. So what is properties of light wave? It can be reflected, diffracted, and refracted. So this is the properties of the wave. And these properties is what we call Braggs equation. Braggs equation. These properties lead us to Braggs equation. The Braggs equation, which we stated this way, if you see the Braggs equation, say 2d sine theta equals to pi lambda. 2d sine theta equals to pi lambda. Why? Is the condition for constructive interference. For constructive interference of what? X-ray, this 2d sine theta equals to pi lambda, the wavelength of the wave, when we needed to have constructive interference. And how does interference come about? You know that we say that X-ray is just like a light wave, which has the properties of reflection, refraction, diffraction, and these properties gives what we call interference. Interference. Are you get what I'm saying? That's leading to what? Interference. And for interference to occur on X-ray, we have this formula which we call 2d sine theta equals to pi lambda. We're going to see this when we go into proper calculation. Number 7, the last properties of X-ray. We say X-ray penetrating matter to an extent governed by density of the material. X-ray penetrate the matter. What is the matter? The human body. Anything that is what we see is a matter. So X-ray penetrates it, and the penetration of X-ray on this body depends on the density of that body. If the density of that body is higher, the penetrating power will be low. If the density is lower, the penetrating power of X-ray to go into this body will be higher. So we now say that X-ray has a penetrating power which depends on the density of the material in which is about to pass through. So if the material has a higher density, the penetration